Hello class, today we're going to be learning lesson 4-5 in our algebra textbooks, and this section is all about learning how to write equations of parallel and perpendicular lines. So if you recall about parallel lines, it is two lines that never intersect. And the thing that you probably remember about it is that they have the same slope, which means that they have the same incline. Something new today is going to be talking about perpendicular lines, and what it means for two lines to be perpendicular is that they meet at 90 degrees. Okay? And the special thing about their slope is that not only are their slopes different, but they are negative reciprocals of each other. Okay, so let's just keep that in mind. Let's check this out on actually a picture to see if it really is true. So let's start with parallel lines. I have drawn here two lines. I have a purple line and a red line, and just from looking at it, it does look like they are parallel. It doesn't look like they're going to meet, but just to check, we always need to look at their slope. So you can choose any 2 points on a line and figure out the rise and the run, and that'll determine your slope. So I chose 2 points right here on the purple that are meeting right at the cross section. So if I'm going down, it's going down -1, and if I'm running to the right, it's going to be +2. So my rise is going to be -1, and my run is going to be +2. So that's the same as -1/2. I'm going to do the same thing with the red line. If you can look, I chose 2 points way up here at the top instead, just to show you again that any 2 points you can find the slope. So going down, I'm also going down -1, and I'm running across +2. So this is the same thing that I wrote before. Rise was -1 going down. Run was 2 going in the positive direction, so that is the same answer, -1/2. So what we can gather from this is that parallel lines, again, have the same slope. And this is very important for you to remember in this lesson. Now when we look at perpendicular lines, it's a little different. I said that perpendicular lines meet at 90 degrees. And as good as my eyes are, I may not be able to tell that this is meeting exactly at 90 degrees. So in order to figure out if that's true, I'm going to have to look at the slopes and determine if each slope is actually a negative reciprocal of the other one. So we're going to start with our purple line again. And it looks very similar to the last time. So I have 2 points. I'm going down -1. That's my rise. And my run is going to the right, +2. So this looks like it's the same purple line from before. So the slope is -1 over +2. So that's -1/2. Now let's check out the slope of this red line. I chose any 2 points again on the line. This time I can tell that the direction of the red line is actually going completely opposite from the purple line. It's going to be positive because it's going uphill. So when I'm doing my rise, it's going up +2. And my run is going to the right, +1. So the slope of this red line here is going up 2, and it's running 1 to the right. And that's the same as just +2. Now you can compare these two, -1/2. If I did the reciprocal of that, it would be -2. And if I took the negative of that, negative of -2 would be +2. Or vice versa. The negative reciprocal of +2 would be -1/2. So it does look like this is true. So why don't we do some practice with actual equations? You might be asked the question to write the equation of a line parallel to y equals 3x minus 1 that passes through the point -3, -5. So I'm given a general equation and I'm asked to find another line that is parallel to that. Well, if they are parallel, that means that they have the same slope. So looking at this equation, the slope is 3, so the line that I'm looking for is also going to have the same slope of 3. And it's going to pass through the point -3, -5. Now let's remember -3 would be the x, -5 would be the y. So I'm going to use my slope-intercept form, y equals mx plus b, to calculate the new y-intercept of the parallel line that I'm looking for. So I'm going to just plug in. -5 equals, the slope is 3 times -3 plus b. Let's rewrite this. -5 is equal to -9 plus b. I still want to get b by itself, so I'm going to add 9 to both sides. And when I do that, I find out that the y-intercept is actually 4. So using the slope-intercept form, y is equal to, I know that my slope is going to be 3, so 3x plus my new y-intercept is 4. And I've successfully written the equation of a line parallel to y equals 3x minus 1 that passed through the point -3, 5. So why don't we do this again with a different equation and a different point. So again, I'm going to look, I'm finding a parallel line to y equals -2x plus 1 that passes through -3, +3. So looking here, if they're parallel, they have the same slope. So the slope of my new line is going to be the same. It's going to be -2. And it's going to be passing through -3, 3. So again, -3 is my x, +3 is my y this time. So let's use our slope-intercept form. Y equals mx plus b, and let's just plug it in. So let's see here, my y this time is +3, my slope is -2 times -3 plus b. -2 times -3 is +6. I need to get rid of that 6, so I'm going to subtract it on both sides. And my b this time is going to be -3. So just like I did before, let's write our equation. Y equals, the slope is -2x minus 3. And I have written the equation of a line that is parallel to y equals -2x plus 1, and it passed through the point -3, 3. So why don't we practice this, but writing equations that are perpendicular to one another. So this time I'm given the equation y equals 2x plus 3. This is the equation of a line, and I'm trying to find a line that's perpendicular to that passes through the point 4, -5. So if they're perpendicular, what we learned earlier was that the slope is going to be the negative reciprocal. So if the slope I'm starting with is 2, the reciprocal of 2 would be 1/2. And if I'm finding the negative reciprocal, I would add a negative sign. So the slope of my new line is going to be -1/2. And just like I did before, I'm going to look at the point that I have, 4, -5. The 4 is my x, the -5 is my y, and using the slope-intercept form, I can find the y-intercept. I'm going to plug in, y is -5. My slope this time is -1/2. That's really important, remember? It's not the same slope because they're perpendicular. It's the negative reciprocal. Times 4 plus b. Rewrite this. -5 is equal to -1/2 times 4 is -2. And to get the b by itself, I'm going to add 2 to both sides. -5 plus +2 is -3. And I have found my y-intercept. So one last step. Let's write our equation. The slope this time is -1/2, so make sure you put in the correct slope times x, and my y-intercept is -3. So this equation is a line that's perpendicular to y equals 2x plus 3, and it passed through the point 4, -5. So let's do one more just like this to get some good practice. We're going to write the equation of the line perpendicular to y equals 4x plus 2. That passes through 4, -2. So let's look at our slope. If we're starting with the slope of 4, the reciprocal of 4 would be 1/4. And to make it the negative reciprocal, I'm going to add a negative sign. And it's passing through the point 4, -2, where 4 is the x, -2 is the y, and using the y-intercept, or the slope-intercept form, starting with y, I'm going to plug in the values that I have. So y is -2, the slope is -1/4, times the x this time is 4 plus b. Rewriting this, -2 equals -1/4 times +4 is -1 plus b. To get b by itself, I'm going to add 1 to both sides. -2 plus +1 is -1. And that is going to be my y-intercept. So writing my equation, y is equal to, the new slope is -1/4 times x minus 1. And there we go. I've created another line that's perpendicular to y is equal to 4x plus 2 that passed through the point 4, -2. So the last thing that we're going to look at now is looking at 3 different equations, and what we're going to determine is if any of them are parallel to one another or if any of them are perpendicular. So to do that, we basically need to look at their slope. And for that, we need them all to be in slope-intercept form. So looking at the first one, equation A, y is equal to 5x minus 3. And as you can tell, we already know the slope. It's in slope-intercept form, so the slope of this line is +5. Looking at the next one, equation B, x plus 5y is equal to 2. Now this is not written in slope-intercept form, so I need to do a little bit of work. I'm going to subtract x on both sides. So rewriting this, I have 5y is equal to -x plus 2. I still need to get the y by itself, so I'm going to divide both sides by 5. The 5's there will cancel out, and y is equal to negative, there's an invisible 1 here, so -1/5 x plus 2 divided by 5 we can leave as 2/5. So now I have it in slope-intercept form, and I can see that the slope of this line is -1/5. Okay, looking at equation C, it also is not written in slope-intercept form. So I need to do a little work. I'm going to add 2x to both sides, because my goal is to get y by itself. So I'm left with -10y is equal to +2x. Final step, divide by -10. And y is equal to 2 divided by -10 is -1/5 x. The y-intercept here is missing, so that means it's 0. But all I'm looking for is the slope. And I can see that the slope of this line is also -1/5 x. Or, I'm sorry, just -1/5. So looking at these 3 slopes, I can already tell 2 of them are exactly the same. Both B and C are the same slope. They're -1/5. So that means that lines B and C are parallel. Also, when I'm looking at this, I can see that 5, if I take that slope and I do the reciprocal of it, I would get 1/5, and the negative reciprocal would be -1/5. So this is telling me that not only is A perpendicular to B, but line A is also perpendicular to line C. So line A is perpendicular, it's a long word, to B and C. and I'm done.